Question 3, how many moles of platinum are in a 455 milligram ring of pure platinum? Okay, so what we're looking at here, I can see that I am given 455 milligrams of platinum. And we need to remember that platinum is PT. And what am I trying to find? I am trying to find moles of platinum. So how many moles of platinum? And what are the conversion factors? Well, I know that I can convert from grams to moles using molar mass. So my molar mass of platinum, I can go from grams of platinum to moles of platinum. And let's look at the periodic table to get that number. Let's find platinum. So platinum, I know it's a metal. It's charging vary right here. 195.08. So grams of platinum would be downstairs, moles of platinum. 1 mole, 195.08. So that allows me to convert from grams to moles, but we're given milligrams. So we'll need to also use our prefix. So remember that 1 milligram contains 1 times 10 to the negative third grams. That's equivalent to, if you have a -3 downstairs on that ratio, this is the same as 1 times 10 to the positive third milligrams in 1 gram. And that'll be helpful because we're going to use milligrams to grams and milliliters to liters a lot. And remember, 1 times 10 to the third, this is 1,000. So that's a conversion that I do a lot, is that 1 gram contains 1,000 milligrams. So let's go ahead and set up our solution map. So I'm going to start with my milligrams of platinum and first convert to grams of platinum because I know I want milligrams downstairs of platinum, grams of platinum upstairs, and 1 gram contains 1,000 milligrams, and then grams of platinum to moles of platinum using, so MM will be our abbreviation for molar mass. The mass of 1 mole, and that's the number from the periodic table. And I need grams of platinum to cancel, moles of platinum to convert to where I want to go, and 1 mole, 195 point, I think we said 0.06, but let me double check. Periodic table. Platinum, 195.08. $195.08. And then bring down that number so we can solve. 455 milligrams of platinum. And I'm going to be specific with my units, right? Not just grams and milligrams, but grams of platinum, milligrams of platinum, moles of platinum, et cetera. So we can double check and cancel. Milligrams platinum upstairs, downstairs cancels. Grams platinum upstairs, downstairs cancels. I'm left with moles of platinum and sig figs. 3 sig figs, unlimited from the metric chart. And my molar mass from the periodic table has 5 sig figs. So my answer, I'm going to want 3 sig figs. So on the calculator, what am I going to type in? 455 divided by 1,000 divided by 195.08. Enter. Let's see what we got. So 455 divided by 1,000, divided by 195.08. And I got 0.00233323 moles of platinum. So with 3 sig figs, let's see, what would that be? 0.00233. We don't round up because remember, after that last sig fig is less than 5 moles of platinum. And in scientific notation, 2.33 times 10, that initial number is less than 1. So a negative exponent, let's see, 1, 2, 3, negative 3 moles platinum for our final answer. Questions on number 3? So we're given milligrams. We want to find moles. Remember, grams to moles is molar mass. To use a molar mass, then we need to convert from our milligrams to our grams. And then what was new? So we memorized the prefix chart. 1 milligram contains 1 times 10 to the negative 3rd grams. Mathematically, a negative 3 exponent downstairs is the same as a positive exponent upstairs. That's the same as 1,000 milligrams in 1 gram. So that's a conversion I'll be using a lot in these, in this chapter and the next.
So, since they're equal statements, we could have put 1 times 10 to the 3rd milligrams on top too.
You could have just as equivalently written 1 times 10 to the negative 3rd grams of platinum for every 1 milligram of platinum. This would be equivalent to that.
Oh, okay, thank you. Because I had it like that the first time and I thought it was wrong.
And you should have gotten the same answer. And the reason I can do that,
Yeah.
Because on the calculator, remember 1 times 10 to the negative 3rd is 0.001. 1 divided by 1 times 10 to the negative 3rd is just 1,000. So if you have 1 over 1 times 10 to the negative 3rd, it's the same as 1,000 over 1. They're just mathematically equivalent. And this is just kind of remembering our rules of exponents, which we go over in math class. And then if you don't use them, no reason to remember it. So just kind of a little review there, just what's convenient. But again, if you have this memorized and you want to stick with it, stick with it. You're going to just see a couple of different versions as we work through the more common prefix conversions in the class. Good question. Any other questions right now? Okay, let's look at example number 4. What is the molar mass of ammonium nitrate? So this is a good review for nomenclature, polyatomic ions, writing neutral compounds of ionic formulas. So ammonium, NH4 plus, and remember ammonia is the neutral one, NH3. Nitrate, 8 is more than 8. Nitrite is NO2 minus, nitrate is NO3 minus. So if I have a +1 and a -1 ion, a 1-to-1 ratio makes that neutral. So ammonium nitrate, the chemical formula is NH4 NO3. To get the molar mass, remember we have to look at periodic table. So for ammonium nitrate, we're going to count how many of each atom we have and the mass of each from the periodic table. So for nitrogen, I have 2, hydrogen, 4, and oxygen, 3. So we're going to look at the periodic table for the mass of nitrogen, hydrogen, and oxygen. Okay, nitrogen has a mass of 14.01. I'll write that down. Oxygen, 16.00. Hydrogen, 1.01. So nitrogen, 14.01 grams per mole. Hydrogen, 1.01 grams per mole. Oxygen, 16.00 grams per mole. We're going to multiply through and then add. So that would be 28.02 grams per mole for the two nitrogens and ammonium nitrate, and then 4.04 grams per mole for the four hydrogens and ammonium nitrate. And 48.00 grams per mole for the oxygens and ammonium nitrate. And we're going to now add these together. So 48.00 plus 4.04 plus 28.02, and that gives us 80.06 grams per mole, which has a conversion factor, 80.06 grams of ammonium nitrate, NH4, NO3 for every 1 mole of ammonium nitrate. And that is how we would write it as a conversion factor. So this is a good review on polyatomic ions, on writing neutral ionic compounds, and then lastly, calculating the molar mass. So the mass of 1 mole. So you get how many of each atom is in that chemical formula times the molar mass from the periodic table for each element present, and add them together, and then writing that as a useful conversion factor. Questions?
I have a bit of a silly question, but
Yeah.
the charges on the polyatomic ions don't make a difference when we're counting how many of the atoms are, right?
The charge doesn't matter, but you need to know it's a 1-to-1 ratio. So if you thought this was like a +1 and a -2, ammonium nitrate would be NH4 2 NO3. But the
Wait,
charge,
could you repeat that?
so the charge itself doesn't come into account in the molar mass, because you have 1 less electron here, 1 more electron here, they cancel each other out. But let's say you made a mistake by thinking you had ammonium was this, but let's say you thought that nitrate was NO3 2-, then ammonium nitrate would be NH4 2NO3. And so you would get the molar mass of the wrong compound. So that's the only way the incorrect charges would affect this problem. Is that what you're asking about?
Yeah, thank you.
You're welcome. So the charges are important to get this formula. So this would be, again, if a student made a mistake, what you would do. I'm going to cross this out just so you realize this isn't the right thing to do. But let's say you did this on an exam. This was an exam, like exam 2 question, and you did this, you would get partial, like let's say it was a 4-point question, you probably get 3 points where you did everything correct. You just had that charge wrong. Any other questions on this part?
Thank you.
You're welcome. Okay, let's look at example 5. What is the mass of 4.55 times 10 to the 23rd copper atoms? So we're given, let me zoom in a little bit. The number that we're started with, 4.55 times 10 to the 23rd. Copper is Cu atoms. And we want to find how many grams of copper. So again, being specific, right? Grams of copper, copper atoms, conversions. So if I have copper atoms, that's Avogadro's number. Remember, is 6.022 times 10 to the 23rd. And in terms of atoms, that would be atoms of copper in 1 mole of copper. Or I could write down 1 mole of copper for 6.022 times 10 to the 23rd atoms of copper. And which conversion factor will I use? It depends what I'm starting with and what I'm converting to. So this will allow me to go from atoms to moles of copper. So let's think about our solution map. I can go from what I'm starting with, CO atoms, to copper, to moles of copper, and using, remember, Na is my abbreviation for Avogadro's number. But I want to get to mass, and we need to remember mass is going to be in grams. So moles of copper to grams of copper. And remember, I convert from grams to moles or moles to grams always using my molar mass from the periodic table. So my molar mass for copper, 1 mole of copper has a mass of 63.55 grams of copper. And that number, again, comes from the periodic table. So finding copper is right here, 63.55 grams per mole. So that's another conversion factor, or 63.55 grams of copper for every 1 mole of copper. Okay, which do I use? It depends where I'm converting from and to. So for the questions before I start writing down conversions below my solution map. Okay, so we're going to start. I'm starting with copper atoms. So I need copper atoms downstairs. And I need moles of copper upstairs. So looking at this, Avogadro's number, the number in front of the mole is always 1. So we'll use this one. I'll use this conversion factor here. So I want moles upstairs, atoms downstairs. So 1 mole contains 6.022 times 10 to the 23rd. And now I need moles of copper downstairs to cancel and grams of copper upstairs to give me my target units. So now I want moles of copper downstairs. I'm going to use this second conversion factor as well. And I know that 1 mole from the periodic table for copper has a mass of 63.55. So it's important to remember the number in front of mole for Avogadro is always 1. For molar mass is always 1. So now we can solve. 4.55 times 10 to the 23rd copper atoms. And now let's check our units. Copper atoms cancel. Moles of moles of copper cancel. I'm left with grams of copper, and that's what I'm looking for. Sig figs. 1, 2, 3. Avogadro has 4 sig figs, and that's 6.022. And molar mass has 4 sig figs. So my answer, I do want 4 significant figures. I'm gonna write, so what do we do on the calculator?
Wait, sorry, Professor, we want 4 and not 3?
We want 3, thank you. Sometimes I cruise on autopilot and my brain isn't thinking properly. So thank you. Good eyes. Appreciate you mentioning that, catching that, and saying something. 3, 4, 4, and smaller number is 3, we want 3 sig figs. So on the calculator, you start with a given, upstairs multiply, downstairs divide, ignore the ones. So 4.55 times 10 to the 23rd divided by 6.022 times 10 to the 23rd times 63.55. No parentheses needed if you're using your EE button properly. And we went over this with a couple of you. So e to the 23, every calculator is a little different. So the key is to learn to use yours. Divided by 6.022 E23 times, I'm gonna move this over, 63.55. and then enter. And let's see what we get. So 4.55 e to the 23rd divided by 6.022 e to the 23rd. Those exponents will cancel. Times 63.55, enter. And I got 48.016, which to 3 sig figs, 48.0 grams of copper.